Let us do a nectar question. 2015, question number 10C, Roman 2, calculation of resonance. Data given. A nectar question, 2015, question number 10C, Roman 2. Calculate the frequency of the vibration in resonance tube of the shortest length of this one. Now, shortest length, you can say length 1. First length for the first resonance to occur is 0.22 meter. And the second length, the length for the second resonance to occur is 0.47. We ask you to find the frequency equals to how much, but we have to know the velocity of the sound in air equals to 340 meter per second. This is constant velocity of the sound in air. Now we say for first position of resonance, first position of resonance, as we have drawn for the previous question, first position of the resonance. Now if there is in the collection, this is the length, that is the L1 from here up to here. This you can see wavelengths over 4, or a half 1 over 4 times wavelengths. Now we can say our wavelengths over 4 equals to length 1 plus in the collection. This is equation 1. Second position of resonance, that is we drawn here second position of resonance, giving a simple sketch that a student can digest a lot of knowledge. Can gain enough knowledge. We are just making a simple sketch in order a student to have a knowledge on how to draw this one. Now if this is in the collection, this is length 2 from up here up to here. Length here up to here, quarter, we say 3 wavelengths over 4. Now we say 3 wavelengths over 4 equals to length 2 plus in the collection. This is equation 2. Now we subtract the equation. We say subtract equation 1 from equation 2. Equation 2 is equal to 3 wavelengths over 4 minus wavelengths over 4 equals to length 2 plus in the collection minus length 1 plus in the collection, this one. Now this one, you get 2 wavelengths over 4 is equal to length 2 plus in the collection minus length 1 minus C. Now C and C we cancel out. 2 to 4, it will be wavelengths over 2, which is equal to L2 minus L1. Place over 1, once we cross multiplication, you get wavelengths is equals to 2 bracket length 2 minus length 1. Now wavelengths will be equal to 2 bracket length 2 equals to 0.47 minus length 1 0.22, this one. Wavelengths will be equal to, we take it 2 times bracket 0.47 minus 0.22. The answer will be 0.5. Will be 0.5. The answer will be 0.5 meter. This is the wavelength. This is the wavelength. Now we say from velocity equals to frequency times wavelength. We are finding frequency. Frequency times wavelength equals to velocity divided by wavelength Get the frequency equals to velocity over wavelengths. Now frequency will be equal to velocity 340 meter per second over wavelengths, which is equal to 0.5. Now frequency will be equal to 340 divided by 0.5. Get the frequency is equal to 681 Hz. Now this will be the frequency of a vibrating string, or the frequency will be the frequency of the vibration in resonance. This is the frequency of the vibration in resonance. This is NECTA 2015.